Hello, I was just hold on. Trying to see if this is working. Not sure what's going on, but I guess yeah, I think that's all right. That is all right. So today, like I said, we're going to go into pointers and memory addresses and all of that. So we can first look at this part. I'm just trying to see if my audio is working. I'm not sure what's going on. That is all right. All right. Okay, cool. It's working fine now. I guess sorry, my setup has changed a little bit, so I'm trying to like fix things to make it look okay. Anyways, hello guys, good evening. So today I'm just going to go, today is going to be really brief but like worthwhile, because I'm going to like really cover an important topic in C. All right, it's going to be about pointers and also memory allocation and stuff. Stuff relating to memory, topics relating to memory and so on. Actually, I'm going to be making use of these two websites because I actually I got the introduction from this website. The link is in the description, by the way. But as you know, one resource is not enough, so I just try to like get more explanation to really understand what's going on here. I don't know what's happening to my stream. That's not good. That is not good at all. The videos are lagging. I mean the stream is lagging, sorry. So I'm just going to try my best to still record regardless of how bad it is. Hey. So yeah, pointers are one of the most feared things in C, apparently. In fact, they are one of the things that make the language challenging at all. But why? So when you read through this, you understand what pointers are. Not right off of the bat, at least you actually get an introduction to pointers. But an interesting place to start from is this place here. So you get to know how memory addresses work in C. So when you put an ampersand before a variable, right, it means you are trying to get the the address in memory for that particular variable. So let's take a look at a practical so let's just do this. Of course, we are going to be using Vim, so I'll just say index.c, and we're in Vim. So let's start with our preprocessor directive. So we can include stdio.h like this, int main. I mean, you can also, usually we do int main, but you can also do void main like this, and it will still work just fine because we are not returning anything. So let's create an integer called age, right? We'll just create it like that. We can give it a value actually. So let's make it equal to, say, 3 or 5. Okay, and we can say printf, and we want to print the value. Well, first of all, print the value of the variable and then print the memory address of this variable. Memory address is simply where this variable is stored on our RAM. So we can do it this way. So say okay, let's say the value is so to print an integer, we need the format specifier, and then we pass in the integer we want to print. So it's going to be age, and then we can also say print f. So now let's print the address in memory of this variable. So do it like this and say the address is what's the format specifier for printing addresses? Is going to be p. So p meaning pointer, so we can just do that. Is p is, so you put the ampersand before the variable name, and then we can close it like this. Yeah, we are done. So okay, then we can come to this side, write it, and let's vertical term, I think vertical term, to open the terminal. Okay, just updating CSH quickly. So can just clear this off, and then we can do let me see. Okay, that's not going to work, so let's simply try to compile this code. Index.c, compilation was successful, and now we can print out what is compiled. So as you can see, we have the value of the age variable is 5. The address in memory is this address here. Now this is going to be different for everybody, especially on every computer, because we all have separate systems and different RAMs. So this is actually where this variable is stored on our RAM. Okay, and I think if you did something like this, if you print it again, it's going to change. Every time you try to print it out, it's going to change, because I mean the RAM is working and reallocating other addresses to different variables, right, or different stuff that your computer is doing at that point in time. So that's a bit different. Sorry, let's just do this. Okay, so now come. Bobby. You can pass it. Ready? I'm streaming. You can just pass. You can't go towards there, but you can come towards there. Sorry guys, I had something to do quickly. All right, so we are back again. We finally got to see how our variables are stored on our RAM, and let me see. So that's like the address in memory of our variable. Let's actually go into more on this topic. So you can see this is how you print it, and this is just what we did. Note the memory address in hexadecimal form, which is 0x and so on. You probably will not get the same result in your program. It depends on where the variable is stored on your computer. Just like I said, even when on the computer you try to print it, you try to get that variable, the address, output the address every time you run the program, it changes. And this is because your RAM is constantly or actively doing stuff and constantly changing the address, right? The address in memory. So yeah, I mean, allocating addresses to different activities that it is performing every time. So which is why the value will not be the same every time you try to print it out. So now we can just try to do something else. Let's continue. You should also note that this ampersand my age is also called a pointer. Okay, we've not even covered the topic, but yeah, we just got a brief introduction to it. So this is a pointer, right? This is the pointer. A pointer basically stores the memory address of a variable as its value. So the pointer's value is the memory address of another variable. The memory address meaning the address where a variable is stored on your RAM. Okay, so you will learn much about pointers, blah blah. Okay, let's go. Yeah, so it's important to know how memory addresses work in C before you go into pointers. So now we are in pointers. So we learned from the previous chapter what memory addresses are, which is with the reference operator ampersand. Now we can now learn about the pointers themselves, right? So like I said, if you we actually did this unknowingly. So you can see we printed out the value and the memory address of this age variable here. So the memory address here, this, when you put an ampersand in front of the variable name, you are creating a pointer. A pointer has a value that is the memory address of a different variable. The address in memory, if that's better. So now, a pointer is a variable that stores the memory address of another variable as its value. A pointer variable points to a data type like int of the same type and is created with the star or asterisk operator. So let's see how we can do that. So first of all, you see here we have a variable called my age, and we created a pointer here, right? So we create the pointer by putting the asterisk in front of the data type, followed by the name of our pointer, so in this case PTR, and then we assign it again the memory address of the variable by putting the ampersand in front of it. So now to output a a pointer, we need this format specifier p, just like what we did before, and we'll get these values here. So I would quickly create a pointer, right, and show you how this works. So come here, let's go, okay, let's go to line 8, and we'll create a pointer by simply, so first of all we need to get the same memory, the same data type of the variables whose pointer we want to, whose memory address we want to assign to our pointer. So it's going to be int like this, and then we say ptr, right, is going to be equal to ampersand age, like this, and then we can say print f, okay, like this, print f, the pointer of age is here. We'll put the p like this, and let's just do it this way. I'll just put this here as well, just to properly format this, and put the ptr here. Now, is it ptr we put or the actual, let me see, yeah, okay, it's ptr. All right, so we can do it that way. We can exit Vim now, we write this file, and let's go to our command line to compile this. So you can compile this like this, sorry, just cc with the name of the file, come on, cc index.c, compilation was successful. Now let's try to print out what has been compiled, and as you can see, the value is 5. The address of the age variable is this address here, which is in hexadecimal form. And now we have the pointer that we just created like this, which also stores the memory address of this variable here, right? It's going to be the same, but whenever this changes, this will also change and give it a new variable. So it's always going to be the same between the pointer or directly printing out the pointer like this. So again, the reason why we do this is if we want to assign the memory address of a variable to a pointer to a variable, right, we create our variable. In this case, this variable is called a pointer by just putting an asterisk in front of it and then assigning it the memory address of that variable. Okay, so let's move on to the next part. Create a pointer variable, name pointer that points. Okay, yes, so now I'm just going to go back to this part here, and we can take a look at something here. There are some really fun stuff to understand from this particular page, right? So let's say from this part here, this is just an explanation, I mean just an introduction, but when you read into 5.1, from 5.1, it says computer memory holds data of all kinds, right? It will hold floats, which is s, int, s, or whatever you have. To make memory easy to cope with, each byte of memory is identified by an integer. These integers increase sequentially as you move up through memory. You can think of it as a bunch of numbered boxes where each box holds a byte of data, or like a big array where each element holds a byte. If you come from a language where with arrays, so again, you can think of you know, how memory stores stuff as a bunch of boxes where each box holds a byte of data, right? So just like in arrays, say something like JavaScript, right? Each element in the array holds a byte, right? Each element in an array holds a byte. The number that represents each box is called the address, right? So things you store in memory are stored in form of bytes, right? And collectively those stuff are called the number representing each of those buses is called an address. So address in memory, the location where you can find them in memory. Okay, now, not all data types use just a byte. For instance, an int, which is integer, often uses 4 bytes, right? A float, but it really depends on the system. So you know what? Let's actually verify that to see whether an integer holds 4 bytes. And I've actually done that before, and I know this, so it is actually true. So if you come here and let's say print f, okay, let's first print f, right? Print f. So I think size of is what you use to get the size in bytes of a particular integer, data type. So what's the format specifier for size of? I think is ZU. So ZU, right, is the size in bytes of ints. So I'm just going to use the age variable again. So in this case, we'll say size of age like this. And then we can close this here. Okay. So let's exit you. Oh no. Let's go back to here. And end of the file here. Okay, so let's append here. All right, so now we are done with that. So let's exit. Let's write this file and come back to this side here. Okay, so now we can compile this code and then we can try to output our compilation results. And you can see the size, 4 is the size of the bytes, size in byte of int, right? 4 is the size in byte of the integer data type. So meaning every integer data type takes up 4 bytes of your RAM. So again, you can see here, here's an example. And memory fun fact, when you have a data type like your typical int that uses more than a byte of memory, the bytes that make up the data are always adjacent to one another in memory. Sometimes they are in order that you expect, and sometimes they are not. While C doesn't guarantee any typical memory order, it's platform dependent. It's still generally possible to write code in a way that is platform dependent, where you don't have to consider this pesky byte ordering. I don't know what that means, but so anyway, if we can get on with it and get around those blah blah blah. Well, let's come back to this place here. So we've done this. Okay, so there is create a pointer blah, blah, blah. Use this here, memory address. Okay, so there's something else called pointer dereference. So in the example above, we use pointer variable to get the memory address of a variable used together with the ampersand, which is called the reference operator. Okay, so reference operator is the ampersand. So doing it this way, we are referencing, right, the memory and address of a particular variable. So you can also get the value of a variable you can also get the value of the variable the pointer points to by using the star operator. Okay, which is the dereference operator. Oh, so even if you assign the address, right, in memory of a variable to a pointer, you can actually get the value from it by putting the star in front of the pointer variable. That's interesting. Let's see how that works. So I'll come here, right? Where were we? Okay, we're here. Let's move down a little bit up and so we say printf, right? So you do percentage. So since it's an integer and want to get the value, so we use the D as our format specifier, and then we can now say here printf is the value from the pointer, right? From the pointer like this. Come on. New line, close, and then let's do star ptr like this. I mean, if you type like that and you do Control N, you can see all suggestions for autocomplete, but I want to use pointer here like this, and then close this. Okay, so let's exit, let's write this, and let's move on to this part here. I'm going to clear everything from here, so let's do it this way. Compile, compilation successful, and then let's print out. So okay, we made a mistake here. There needs to be a new line so that it's properly formatted. So let's come back to the left, back. Okay, forward. I think it will be better if we just do it this way. I'll just insert a new line here, and then we can just write this. Okay, that's my fault. Compilation successful. Okay, now we can see we got the value of a variable through its pointer, right? So that's also possible, and it's called dereferencing. So here we first of all declared a variable and then another pointer, then you reference the pointer through this. So the reference output is here. The dereference output is by putting the star or the asterisk in front of the reference. In front of the pointer, I mean, yeah. Okay, today is kind of slow. Not doing a lot of stuff today. So let's come here. I mean, there's still more to know about pointers. I'm just like trying to learn the basics for now. Obviously, there is more we will need to cover as time goes. But yeah, just for now, this is all we can do. Yep. All right, so there is actually notes on pointers and so on. So note that can we change the value, right, of a variable through its pointer? I mean, it's not here, but I feel if we can access the variable's value by dereferencing the pointer, then there is a chance we can actually assign it a new value through that same method. Let me just try and see if that's going to be possible. So we'll come here, let's move down. Actually, go back up. And let me say just the same way, right? So we just do ptr and then say equal to 60, right? And then printf. This is an integer now, so just a new value. New value is share d, and like this, and then we'll say ptr. Oh, let's just use the age itself. Let's print the age like this and do it this way. So printf this the all right, so win write to the memory, and then we can compile this. Compilation was successful, meaning something good is about to happen. So age should be 60 at the end of the day. Just go age index. Okay, yeah, so the new value is 60, right? New value is 60, and the memory address, I mean the memory address of the variable is still the same. I mean, will it change if the value changes? I'm trying to get that. Sorry, I didn't print it out, so let's try and see if that's going to be the same. So I'll say printf the new the new address in memory is so just do p again, format specifier p. First of all, let's add this here, nicely format it, and then we can say here we have so age. You know what will be interesting? Let's print age, and then I'll do it this way. So p also pointer is, and then I'll just come back here, right? So let me just go word. Okay, let's go back p, and then here append. So first of all, we want to assign age, and then we'll do this. So say here this will be our this will be pointer ptr. Oh, sorry, I did not put the format specifier for the second variable here, so let me do that now. I'll say go back up again, sorry, here down. So let's move all the way to this part here, Actually, just go back a little. E, end of the word, A to append, and we can just say %p as well here. Okay, so now we can just write this, and then so let's clear this out. Compile first. Compilation was successful, and then let's try to print this out. So you can see when the value changes, the address in memory does not change. It's the same here. It's the same as this one here. It's also the same as this one here. So that's actually pretty cool. Yeah. So let's see if we have some other stuff here. Data 48. I should have done this stream earlier, man. Anyways, it's okay. All right, so that's like a little introduction into pointers. Now, there are two ways you can actually create pointers. Note that this sign can be confusing here as it does two different things. Yep, it does. So dereferencing and referencing. So here, this is used for the declaration of a pointer. When not used in declaration, it acts as the reference operator. So good to know. These are two ways to declare a pointer. This and this. Yes, I actually prefer the first because it's more I don't know, it's different and it's just like specific to pointers. Pointers are one of the things that makes C stand out. I still okay. Let me just calm down. They are important in C because they allow us to manipulate data in computer's memory. This can reduce the code and improve the performance. If you are familiar with data structures like lists, trees, and graphs, you should know that pointers are especially useful for implementing those. And sometimes you even have to use pointers, for example, when working with files and memory management. But be careful, pointers must be handled with care since it is possible to damage data stored in other memory address. This is actually true. I mean, we actually saw how the value of the pointer changes every time we run the code, right? So how do you declare a pointer? Here, this is 1, and that's all. All of these other ones are wrong. Yep, correct answer. All right, pointers and arrays. Let's see. This is how you create arrays, by the way, in C. So you wait to get the values for an array. Yeah, to bring the memory address of each one is this. That's correct. Wait, this is strange. I mean, is the array itself not a variable to be stored in a particular memory address? Wait, let me see. If we let's try to get the memory address of a different data type, right? So here I'll create a new file. Okay, let's just let's close the terminal, sorry, and then I'll create a new file. I'll call this arrays arr.c, right? In fact, let's just open them side by side. So vertical split index.c, it's there. Yeah, let me move this one to the left side, so I'll do Control W, left. All right, so now we can come here. Let's insert into this. Oh, not there. Undo that and come to this side. Okay, let's insert here. We'll still, you know what, I've not done this before. Let me see if this actually works. So I'll copy this line. If I do CC will clear the line. So I say Y to yank it and then come to this side. Control G H and then good. That was correct. All right, so we go back up here, delete that line and insert here. So int main here. I can just do this. I'll say I'll create an array, right? So let's come back here. Instead of creating an array, I'll just create a string, right? I think with strings we also do this, which is strange, right? Is that how we create strings? Let's see. User input strings here and there. Okay, no, that's not how. So we do, okay, sorry, my bad. So say greetings. You know what, let's just say greets my string, and then we'll create like this. Just the other way, say age. This is another way of creating strings. Hello, I'll just type hello and LLO. And then the last one will be, I think is this, is it like this, 0 here to end this. This is how I create strings. Printf, right? Printf here. Let me see if I wasn't wrong. Printf C, okay, C, greetings, hello world. Let me just try it and see if I got this wrong, and then I'll just, the format specifier for strings is C for R or char, whatever. I'll just put world here, and then new line, close this and put my string here. Hold on, my string like this. Come back as it, and then yeah. So let's write this. Let's try to compile this. I'll just put the terminal above this one. So I'll just say terminal. Yep. And then we'll say cc, what did I call this? arr.c. Now there's an error. Yep, I knew this would cause an error. So let's go back and check what I did wrong. Okay, it's the other way around. It's not /, it's backslash. Is that backslash or yeah, // is / and the other is backslash. Okay, so let's clear this and come back to the fourth line. So for G, and then end of the file like this. Let's go back a little. So 3h and then back again one more time. Let's just replace this with this. Yep, and that's all we need to do. And then come back here, right, and go back up to this part. Okay, so we can compile this now again. Still didn't work. What happened? It says let me enter this on my strings. What does it print here? What does it say? Oh, is this to do with spaces? SS element is scalar initializer. And with this, just a warning, the code was still compiled successfully, but it will not print out everything. That's strange. Oh, I see why. So actually, this was my fault. So let's go back to this place. Let's go back here. This is what we're missing. Let's insert this. Okay, yeah, I see. So now this should work, I guess. Right. There is still a problem. How do you print out? Hold on. Is this my? It's S. Oh my god. C is for a single character. Sorry. We learn every day. Anyways. So come back here and replace this with S. Oh, finally. Success at last. Okay, now you can see hello world was printed. Now, how do we get the pointer, right, of this string here? So simply by putting the ampersand, but let's see if we can assign it to a new variable. Let's first get it right first of all. So I'll say print f, okay, this, and since it's the pointer, right, we'll put the p there and say is the address of my string. My string like this, and then you know what, let's first break the line, and we can now do this, my string like this here. So now we can exit, right, and compilation was successful. Oh, okay. So the now is the address in memory of each element different from the string itself, and by element I mean each character in the string different from the string itself. Or I mean, I saw that was what was done in the other parts. No, let me just close this window here. All right, let's close that. We can move this window to this side. Let's move this window here. Control, what window are we in now? Here, so we can move this to this side. W capital, yep, like that. That's good. And now we can actually write all our code here. So let's write a loop to print out the memory and address of every character in the string, so to see whether it is different from the string itself. So let's say for, so since it's every character we are printing, we'll create it as char equal to, sorry, for int I, we need to get the size of the strings first of all before we were able to look through, but I'm just going to guess it. So this is like 5. Is it 5 or 6? 6. Yeah, but the length of the string itself is 5, and because of this last one here, I think it's called the null something. Hold on, it has a name. Yeah, the null terminating character. Yeah, that's its name. So because of that, we have more items than usual. So here we can just say I is less than the length of the string, but in this case we'll just put 6, right? And then we'll do I plus plus like this. And then here we can just say print f the address of so I'll put here the address of C here, because we want to print each character is since it's going to be P, so and then we add this here, the line break like this, and then we say here the first one will be my string, so my string at I, and then the second one, the at I like this, and the second one will be P, right? So it's going to be ampersand my string at I. Okay, just like that. Close it, and like this. All right, then we can just do here. Okay, that's all we need. And yeah, so let's save this. Let's go to our terminal to compile this. The compilation was successful indeed. Let's print out the output. Now you can see the memory in address is this. The memory address of the string is this here. As you can see, it's you can notice a pattern here. I mean, it's almost the same except the last number. The first item has the same, the first item in the string has the same value as the first item, the first character's position or address in memory is the same as the entire string's address, and then every other character's address progressively increases by 1 And you can see they have 3 here, 4, 5, 6, and every other thing here. So it means they are basically in the same space, right? But I'll try to understand what this means. I mean, the string can be stored somewhere, and every other item is stored probably adjacent to it. I don't know, but we'll find out. Yep. Anyways, I think that's all. We just covered pointers, the referencing pointers, getting the memory the memory address of variables from using pointers, right? That's all good. And thank you all for joining the stream today, and we will continue certainly on the next one. Let me quickly save this, pass them to my GitHub. So I'll just quit the terminal here. Hold on. Yep, and then we'll just write this. Okay, so we can quit this as well, right? We'll quit Vim to ls. See here, cd. Here we have a new one, so say git add. Yep, chapter 9. Git commits -m chapter 9 pointers and memory address practice exercise, like this, and then git push origin main. Yeah, I always try to okay, so you can have access to this code from my GitHub. Yeah, anyways, oh sorry, Basil, how are you doing? Oh yeah, I'm sure you've seen what I wrote. Yeah, it's a C program. Yeah. All right. Thank you guys, and I will see you on the next one. Certainly on the next one.